I'm going to introduce myself and my co-host. So my name is Tom Warfield. I am the training manager at Westell in the in-building wireless division. And joining me today is Jonathan Davey. He's works with our distributors. Jonathan, you there to introduce yourself?
Yes. Hi, Tom. Hi, everyone. Again, my name is Jonathan Davey, in-building wireless director of sales for distribution. So any questions afterwards, I'm excited to help.
Thanks, JD. And speaking of questions, they can be typed in, and we're not going to answer them during the presentation, but at the end of the presentation, we'll certainly get to any questions that you type in. And if it's technical in nature, I'll be answering it. If it's salesy in nature, JD will be. Just a quick overview of our Westell sales team. We have 3 divisions. Up there in the blue is the Northeast. And I'm pretty sure by now, if you're dialing in and you live in that blue area, you know Bill Dow. He's been with us forever. But just in case you don't, there is his email address and phone number. And by the way, this presentation will be shared with those who are with us. And so this information will be readily available to you. If you're down in that orangish, yellowish area, that is David Merkel. David's fairly new to our team, and so if you have not met him yet, please reach out to him. And again, there's his email address and phone number. And that big gray area over on the West Coast, it's a little bit of a transition. We're hiring a new person. So for now, our VP of Sales, Bob Joslin, will be handling that. But in a couple of weeks, expect to see a new name and face there. And as mentioned earlier, for distributor information, that would be JD. We also have our support team. Donna is on our customer support. She handles any kind of expenses, things like that. Kevin is our technical support. Have any problems, you're out in the field and you have a question on the equipment, give Kevin a call. And then we have Zach, sales engineering, pretty much our design team. If you need a design or have a question on a design, Zach is your man. Most of our customers get the Westell BDAs through distributors, and these are the current list of distributors that we have. All right, so let's get going on the actual product itself. Today's agenda will go over this new 2.5 watt version of the CS45. We've had the 0.5 watt version for a little over a year now, so this is the new 2.5 watt version. We're going to talk about the dimensions and weight, the mechanical layout, electrical specifications, the RF specifications and features, and then we'll talk about the battery backup unit that goes along with it, and just some quick graphical user interface screenshots to show you how easy it is to program this thing. And then something this 2.5 watt version does that the 0.5 watt doesn't is it can be converted into a fiber DAS master unit. So we'll talk about how that's going to work. And then we'll talk about how to order the BDA and also the kits that we sell. And all that ordering information. I elected to start this presentation basically by talking about the dimensions and weight, which isn't necessarily the most exciting thing you can talk about when you have a BDA, but for this product, it's real high up there on the list of that's really nice. It is a fairly small unit. So this is a 2.5 watt per band BDA of power. And so it weighs about 26 pounds, and you can see the dimensions there, about 14 inches by 16 by 9 by 6 1/4. So it's fairly small, fairly light, and it's just really easy. You can hold this thing up on the wall by using one hand and use the other hand to drill the mounting holes. It's that light and that small, so very nice. From a mechanical standpoint, it's obviously NEMA 4. That's pretty much a requirement, but there it is. It is UL 2524 listed and FCC approved. So we got 4 conduit ports on the bottom. We have the one port for the fiber DAS system, the other one for the BBU connections, the 12 volts, and the alarms that come from the BBU. And then the alarm port that goes to the monitor modules of your fire alarm control panel. And finally, if you have a remote annunciator, port for that. We have 2 N-type female ports on the top for the donor and service antennas. Down there on the bottom, we also have the graphical user interface RJ45 commissioning port. Inside the unit, we have compression screw terminals for alarming. That's not shown on this screen. Obviously, it is wall mounted. It does have two latches, of which one of them is lockable. And as you can see, it has a built-in annunciator, just like our half-watt unit, that shows all the UL 2524, NFPA, and IFC 510 requirements, which is the oscillation detection. And if you happen to be in an area that doesn't require oscillation detection, it probably will soon. The NFPA will be calling that out as well in the next edition. Inside the unit, we have the alarm annunciator and buzzer. That's on the lid. Inside, we have one module there. That module is what I call the interface module. Anything that gets connected to the outside world gets connected to that module, such as interface modules for the fire alarm control panel, the BBU, the power, and its alarms get plugged into there. The transmit disable feature, which turns off the uplink and downlink power amplifiers with the push of a button. And the web and local graphical user interface ports are there as well. Over here in the lower left-hand corner, we have the on-off switch, turns the DC on and off. We have that big red button, which has a couple of different functions. If you just simply tap on it, it mutes any audible alarms. If you press and hold it for, 3 to 8 seconds, it resets the unit as like turning it off and turning it back on. And if you press it for a little more than 10 seconds, it actually does a factory reset and resets all the parameters to how it was when it left the factory. And this little module here, if you're familiar with the half-watt unit, you definitely don't see this on the half-watt unit. This is your downlink and uplink signals to feed the fiber DAS system. So that's definitely different than the half-watt. Some electrical specifications, it does operate off of 12 volts, just like the half-watt. So a lot of BDAs, in fact, most BDAs operate off of 24 volts, but not the CS45s. They operate off of 12 volts, so just a single battery in the BBU. Power consumption at the worst is 123 watts, and there's the operating temperature, minus 30 to 50 degrees Celsius. From RF specifications, this is a 700-800 dual band BDA. So not VHF, not UHF, but 700-800. And frequency-wise on the downlink, goes from 769 to 776 on the 700 band, and 851 to 869 megahertz on the 800 band. And you can see the corresponding uplink frequencies. And notice that in both the downlink and the uplink, FirstNet is not included. FirstNet from downlink is 758 to 768, so that is not included. So FirstNet is blocked by the duplexer. The donor and service ports, those N connectors at the top of the unit, we do VISWAR and return loss measurements on both of those. Other specifications include 34 dBm, which is the 2.5 watts of downlink output power per band coming out of the service antenna port. And that's adjustable. It can be as high as 34 dBm, but it can be as low as 4 dBm. And you can adjust that in 1 dB steps. And for the uplink, we have 27 dBm power per band. And once again, it has a 30 dB range, so you can go all the way to 27 dBm, all the way down to minus 3 dBm, again in 1 dB steps. As far as gain is concerned, we have 90 dB of downlink gain, adjustable from 60 to 90 dB in 1 dB steps. And for uplink gain, we have 80 dB, which is adjustable again in 1 dB steps from 50 dB to 80 dB. One really nice feature about this unit is we have a total of 96 filter pairs. And those filter pairs can be assigned to either the 700 band or the 800 band in groups of 8. And we can have a maximum of 80 filter pairs per band. And by filter pairs, I mean downlink and uplink. I'm not saying they are two different filters, even though they are. We're just going to call them one. So what that means is if you have up to 80 filters in one band, let's say the 800 band, you can have 16 filters in band 1, which would be the 700 band. And as you can see, as you go up in groups of 8, you can see the remaining amount of filters for the other band. So jurisdictions that have a high count, like I'm looking at you, Orange County, California, which has like 37, 38, 800 channels, but then a handful of 700 channels. This is perfect for that type of market. You can have a filter for each one of those channels and still have plenty of channels left over for the other band. The DSP passbands that we have for Class A are 12.5, 50, and 75 kilohertz. For Class B, it's 150 kilohertz. Or we can bypass the DSP altogether and go into wideband mode, and it would cover the entire frequency range, which was on that earlier slide. Some other features is we have fast AGC and squelch, which is P25 phase 2 compliant. With P25 phase 2, you have that TDMA, time division multiple access. One conversation is on for about 28 milliseconds, and then 1 millisecond later, the second conversation is on for about 28 milliseconds. And it's very important that if those two conversations are having like a near-far type effect, where one is close to an antenna and one is far away from an antenna, that the BDA's AGC can quickly change from a lot of AGC to no AGC within 1 millisecond. And that's also true with the squelch, and this unit does do that. We have a dynamic range of 60 dB, so going back again to that near-far effect, as long as there's less than 60 dB of difference between the near and the far, the AGC should be able to take care of that. A recently introduced feature to the half-watt version and also this new 2.5-watt version is automatic uplink amplifier shutoff. And this is initially a PCERN up in the Seattle area requirement. And what they wanted is if no first responders are in the building, so no one's hitting push to talk and there's no uplink signals breaking squelch, if that happens for 1 solid hour, they want the uplink amplifier to turn off. And when that uplink amplifier turns off, this thing transmits nothing. From an uplink perspective, there's no signals, there's no noise. It's like it's turned off. It's a wonderful feature. And then as soon as an uplink signal comes on and breaks squelch, the thing turns on really super quick. And everything works as it should when first responders are there, and it shuts up when first responders aren't there. And that happens automatically. You don't really even have to do anything. It just does it. And correspondingly, we have an uplink squelch, and that's adjustable from -100 dBm to -70 dBm. We also have a option for what we call dynamic AGC, which can be turned on or off depending on the circumstances. So what dynamic AGC is when dynamic AGC is on, how much power does each channel get changes dynamically. So here's a scenario where there's 4 filters programmed. If we have 4 filters programmed and dynamic AGC is on and only one signal is breaking squelch, that one signal can get full power. But if 2 signals break squelch, then the BDA is going to take its full power, divide it in half, and each of the 2 channels that's active will get half the power. And then it follows that for 3 and a 4. So how much power does each channel get? Well, it depends. It dynamically changes depending on how many people are using the system. Now, if you turn dynamic AGC off, it doesn't matter how many people are using the system. The BDA will automatically power divide each channel by 4. So it's very consistent. Dynamic AGC off gives you consistency. Dynamic AGC on gives you more power per channel, which more than likely would happen because what's the chances of all the filters being active at the same time? But which one's right, which one's wrong? And the answer is it depends. It's up to what your design goals are. Now, it does have an annunciator in the front lid, but sometimes you need a remote annunciator. We have a remote annunciator. It's the same one that we use for our other products. The CS40 uses this annunciator, and it works as just the same as with the CS45. It connects to the CS45 through a Cat5, Cat6 cable. And that Cat5 cable can be 3,000 feet away from the CS45, and it will still work. It uses RS485, so we don't have any power over Ethernet limitations. Now, how do you commission this thing? It's really simple. You just get a computer, you open up an internet browser, Chrome, Edge, Safari, whatever. And no separate application is needed, and you just simply connect your computer's RJ45 port. A lot of computers nowadays don't have that, so you buy an adapter like shown there on the left. Connect up your Cat5, Cat6 cable to that GUI port that's on the bottom of the unit, and you type in the IP address 168.192.150.1. That's the same IP address for all Westell products. And we've even commissioned one of these BDAs with a smartphone. We just use one of those adapters and turn on the browser, and bam, you're there, good to go. Here's some quick screenshots to show you how simple the graphical user interface. This is what you would see when you first log in, and this is where you go to do what you want to do. That green oval there, if you click on that, you'll get all the alarms. Then we have RF configuration, system settings, alarm test, and if you're connected to a NOC, a SNMP trap receivers. And finally, once everything is said and done and AHJ approved, you can do a backup configuration, which stores all the configuration of the BDA. And then you can restore that configuration later on if you need to, or restore that configuration into another project that uses the same filters, let's say, for example. So it makes other projects in the same jurisdiction much easier to commission with that backup and restore. And here's a screenshot of the alarms. You can see it's very easy. All the alarms are shown. If they're shown in green, it's good to go. Yellow means something's not quite right, but it's probably not affecting, like, for example, the door open. And then we have not shown here, but they're in red. That's pretty bad. Something's probably affecting the RF. And then we have the white with the crossed out names. Those are masked alarms. So if you don't have a remote annunciator connected to the CS45, that would be one that you would probably mask, as we don't want to get alarms for something that's not really an issue. And RF configuration, it's really straightforward. You just click on how many filters you want to activate, put in the downlink center frequency. The uplink center frequency fills in automatically. There's a drop-down box for the bandwidth, again, 12.5, 50, or 75 kilohertz if in the Class A mode. Little slider controls for the gain and attenuation. There's the uplink squelch, AGC level. AGC level is the maximum power output power. So that could go as high as 34 or as low as -3 for the downlink. And for uplink, again, that could go from 20. Downlink is 34 to 4, and uplink is 27 to -3. But overall, it's pretty straightforward. There's no hidden menus. There's no various menus. It's all right there for you to see. Now, the battery backup unit, this is a new battery backup unit. The battery backup unit that we sell with the 0.5 watt CS45 doesn't have enough oomph for the 2.5, so we have a new one for this. So this battery backup unit, the CS19 BBU 005, it's only for the CS45 2.5 watt version. Batteries go into this cabinet, and the charger and alarm detection unit is also in this unit. So the batteries go on the bigger box on the right, and what we call the sidecar over on the left, that's where the AC goes in and where the alarms are monitored and where the battery charger is. So when it comes to batteries, we only have one battery. That's the CS19 BAT 145 AH SLA. You put one of those in, and it'll have battery backup for 12 hours. You put two of those in and connect them in parallel because it is a 12-volt system, then you'll have 24 hours of battery backup unit. Here's a diagram of what it looks like. There you can see the charger on the sidecar on the left-hand side of the unit, and that's where the conduit ports are. One conduit would be for AC in, the power cord, and the other conduit is for the alarms and DC out. The battery backup unit comes with a cable. You just run those through the conduit ports. One of the connectors is for the 12 volts DC. You just simply plug it into that interface module. And the other one is a 6-pin connector. Just plug that in again to that interface module in the CS45. That has your AC, battery capacity, and battery charger fail alarms. Now, one of the things that makes this completely different than the 0.5 watt is it can be converted to optical fiber DAS master. And just in case you're familiar with our CS40 and its fiber DAS, This is a completely new version. This is version 2. So if you're familiar with the CS41, this is different. So pay attention. This new version, by the way, not only works with the CS45 2.5W version, but it also works with our new CS40 UHF and VHF BDAs that now have the fiber DAS connections built into them. Now, not all of them do. There's ones that have them and ones that don't, but if you do have the ones with those connections, they will work with this fiber DAS system as well. Now, the UHF version is available right now for ordering. And the VHF unit, just contact your sales representative to make sure when those are going to be available. And as far as the 2.5W version, it will work with it. Everything should be good to go sometime in the mid of this quarter 1 of 2026. So let's just talk about why you might want a fiber DAS system before we actually talk about the fiber DAS system. Is sometimes a single BDA just doesn't have enough power to cover all the square footage that you need. So very large buildings very often cannot be covered by a single BDA, and this would be one application for a fiber DAS system. Another application is a campus setting with multiple buildings, and every one of these buildings, or the majority of them, need BDA coverage. Putting a separate BDA into each one of those can be expensive. And we have losses from too long of runs of coax cable. So this is another good application for a fiber DAS system. Now, why couldn't you put multiple BDAs into all these campus buildings or multiple BDAs into this very large building? Well, I mean, you can, but you can also expect all sorts of issues. There's multiple BDAs. They interact with one another when you have multiple donor antennas fairly close. You can get oscillations, timing issues, and uplink noise issues. And it's one of those, you might commission one of those BDAs and it seems to work just fine, and you go to the second one and you commission that one, only to find out you messed up the first one. A fiber optical DAS takes care of all of that. Now, here are the new parts to the version 2 of this fiber DAS system. We have one box, can be seen here on the left. We call that the head-end unit, or the HE. The HE is going to convert downlink RF signal into light energy and light uplink signal back into RF for downlink. And it has an annunciator on it, which will show the annunciator of the master unit. And then that is going to get connected to our RE, or remote end. And the remote end has a fiber input, and it will output RF to the remote unit. And the remote unit's RF will get inputted into the RE, and the RE will convert it to light and send it over to the HE. It also has an annunciator on it to show the alarms of the remote. The fiber that connects the head end, the HE, to the RE, the remote end, is a single mode SC APC cable. It has 8 dB of optical link budget, and the reflectivity spec is less than or equal to minus 60 dB. This is an analog system. Analog systems are very prone to reflection issues, so we can't have any reflections. That's the reflectivity spec. And the best way to do that is to use these angled physical connectors, the APC connectors. And it must be an APC connector everywhere. If you have a patch panel, make sure it's APC as well. So how does this all work? So here's our CS45 2.5W BDA connected up to our BBU. The BBU is giving it the red and the black wires. That's the 12 volts. Connected up to the CS45, we're going to have 3 connections. We're going to have the blue line, which is our Cat5 or Cat6 cable. This shuttles data back and forth between the master and the HE unit. We're going to have 2 SMA to SMA jumper cables, one SMA to SMA jumper cables for downlink, the other one is for uplink, and those are represented by the 2 gray lines. And then the head-end unit does not have any power supply of its own, so we're going to have to supply 12 volts to that. That's represented by the red and the black lines. So we're going to supply power, we're going to supply RF, and we're going to supply data. And those will get connected to the HE unit. Once it's in the HE unit, the downlink signal coming from the master will get converted to light and go out the fiber optic cables. We can have up to 4 fiber optic cables coming from the remote. Those fiber optic cables, those are the single mode SC APC ones I mentioned earlier. Now, they do not get connected directly to the remote. They get connected to the RE, or the remote end side. And from a downlink perspective, it's going to convert that light into RF on the downlink. And then those are going to get transferred over to each of those remotes. Again, there's going to be the blue cable, which is the Cat5 cable for the data. We need to shuttle the downlink and the uplink information from the RE back and forth to the master. So those are the two gray lines again, the two SMA to SMA connectors. And the RE unit itself, again, does not have any power supply. So the remote unit will supply 12 volts to the RE. And in this case, as we can see, we have one master unit connected up to one HE unit, and the HE unit can connect up to 4 remotes. So overall, this covers 5 zones. The CS45 master unit can connect to antennas, just like always. And then each of the 4 remotes can connect to their own set of service antennas. So 5 zones consisting of 1 master and 4 remotes. And by the way, the remote is a different part number than the master. The remote only has one RF connector, the service antennas. It does not have a donor port, does not have an uplink amplifier. So it is a different part number than the master. Now the battery backup unit is the same though. Now 4 remotes, not enough? Don't worry. We have a way of expanding this. So this is what I showed you in the previous slide, but just simplified. The master connected to one HE, 4 fiber optic cables connecting up to 4 remote ends. I only show one, but have it say times 4 and then to times 4 remotes. What we can do is we can daisy chain HE units. We can daisy chain up to 3 more units, so a total of 4 HE units. And then each of those HE units connect up to 4 REs, which then connect up to 4 remotes. So under a fully utilized system, we can have up to 16 remotes or 17 zones with the CS45 2.5W version. Now the connections between the HEs, there is a daisy chain option for the Cat5 cable and for the power. But the RF connections, that has to be done externally through a splitter. So this area up here by the master unit, if we had 4 HE units, we would probably put 2 4-to-1 splitters, one for downlink, one for uplink, and then connect them to each of these HE units. As far as part numbers, I'm not going to read the part numbers, but again, you'll have a copy of this presentation. Overall, we have the part number for the CS45 2.5W version itself. And then you can order kits. The kits are very, very popular. The kits include the battery backup unit, and everything gets shipped on one pallet. So you get one delivery, and that one delivery on that pallet will have the BDA, the BBU, and the battery. And the K1 kit would have 1 battery for the 12 hours, and the K2 kit will have the 2 batteries for the 24 hours. And if you needed to order the battery backup unit by itself, there's the part number for that, and there's the part number for the batteries. And I'll mention at this point, everything, with the exception of the batteries, has a 3-year warranty. And that ends my presentation.